Today's topic is first order logic. So there were many problems in propositional logic, therefore we moved to first order logic. So what was the problem related with propositional logic was that propositional logic can deal with only a finite number of propositions or does not permit generalized statements. For example, we are having an example for all x such that x is a strong candidate and x participated in election, then x wins. So here x is a variable, so x can have any name, for example Ramu or Ramesh or Ramya or Sita, any name it can have. So names can be infinite or a large number of candidates may be present, or any variable can be present as a candidate name. So the problem with the propositional logic is that it cannot deal with variables, it has to be a constant. So here as it cannot deal with infinite names or numbers or variables, so this was the problem in propositional logic. So we move to first order logic. So as it cannot deal with variables, so propositional logic can deal with only a finite number of proposition and does not permit generalized statement. So moving to first order logic, first order logic is also predicate logic, is a generalization of propositional logic. In this, infinite models can be expressed. For example, all men are mortal, some birds cannot fly, and it uses symbolic structure comprised of predicates, constants, variable, functions, quantifiers, and logical connections. So what is a terms? Means it also uses terms. So terms is a combination of constant and variable, or constant, variables, and functions. So what are constant like 5, Raju, etc.? They are fixed terms. These values are fixed. So likes Neha, comma cinema. Here it is interpreted as Neha likes cinema. So Neha is a constant. So Neha is a constant term. So here what we mean by constant, that they are fixed term. So what is variable? If x is an employee name, it can have any name. So variable can assume different values over a given domain. As we have already discussed, x can have any value depending on its domain. For example, employee name is the domain of x. And for functions are symbols that denote relation defined in a domain. That is domain, as we have already discussed. Function must return a term. For example, if x is a set of natural numbers, so plus x1 x2 should result on a number which also belongs to x, that is natural number. So x, if we are applying any function on variables, this variable should be natural number like 4, 5 or plus of 4, 5 or anything, and result is 4 plus 5 is 9. So 9 is also a natural number, so this is a valid predicate. So here xi are terms. This xi can be terms like constant, variables, or function, anything defined over some domain. And next, moving to the predicates, similar to function, but their return type should be true or false. So here as we have seen in functions, our return type can be any value, that is 9, or any name or anything depending on the domain, but here return value should only be true or false. For example, similar to functions, but their return type should be true or false. For example, there is a greater than x comma y. It can return only true or false. For example, 2 comma minus 1. So it will return is 2 is greater than minus 1. So yes, so it will return true. For example, another function we are having boy. So is this person is boy or not? So it will return true or false. So some types of predicates are simple predicate. So simple predicates has no variable and also known as proposition. And next is known as property predicate with one variable. For example, dog of x means is this x is a dog or not? Is true if and only if x is a dog. Similarly, if these are two predicates, let p be a function of some variable x1, x2, x3 and so on, and q is also be a function of variable some variables x5, x10 or any x1, x2 two predicates. Then p or q, p and q not of p, p implies q, or all are valid predicates. And for example, if x is a strong candidate, then x is hardworking. So if x is a strong candidate implies x is hardworking. So here x is a variable. In proposition, in this x should be a constant. For example, Ram is a strong candidate, then Ram is hardworking. But here this x can take any value. So strong candidate of x implies hardworking of x. So this can also be written as not of strong candidate of x or not of hardworking of x. Now moving to the quantifiers. Quantifiers can, here it should not be not of, I think it should be as p implies q is not of p or q. It should be like that. So what is quantifiers? Quantifiers can be used to express sentences. There are two basic quantifiers, for all and there exist. They are the two basic quantifiers. So for all denotes universal quantifier and there exist denote existential quantifier. So let there be a set let there be a set. This is the set, and this set can be of a domain. This is a domain and it can have many values, as you can see here. And if it is written like for all x p of x, this means that this predicate p of x or this p of x should be satisfied for all the values of x. And for there exist, there should be at least one value for which your sentence or predicate should be true or exist. For example, for all x, king of x implies person of x. So for all kings, all the kings are some person. So if this all is kings, this all are kings, then this should satisfy that these all are persons. So every element of king will be the person. And for example, holiday of x. So if x can be some as you know 7 days in a week, 7 days in a week. So in a week at least there is a one day, that is Sunday, for which we are having a holiday. So there exists at least one which satisfy this condition. So we have discussed quantifiers, predicates, and functions, terms, and what is first order logic, why it is used instead of propositional logic. Thank you.